equations. And so if you look up here on the board, it says to solve each equation. So what do you think you should do for the very first step to solve that equation for x?
Minus log 2. 2 log.
Close.
Minus
Divide,
6.
take away 6 from both
Take
sides.
away 6 from both sides. So I'm going to go ahead and subtract that 6 from both sides. And then that's going to leave me with 2 log of 5x. And that's going to equal 12. What do you think the next step will be to do?
Can you move the 2 to the power point, to the power spot?
I probably wouldn't.
Never mind.
I would divide by 2. Okay? I would divide by 2. Our whole goal is isolating the logarithm.
Wait,
Because
is that
once-
log 5x, or you just want log by itself?
I want x by itself. So the final step should be like x equals something. And so now, real quick, what number is here, even though it's not written?
1.
10. Okay? So remember, that's the common logarithm. It's log base 10. So I'm going to go ahead and both sides, I'm going to place a 10. Now on the left side, the 10 and the log 10 cancel. It leaves me with 5x. On the right side, I have 10 to the 6th power. Okay? We know that 10 to the 6th power is actually a 1 with 6 zeros. Okay? So how do you solve that for x now? Divide by 5. And so what does x equal?
200,000.
200,000. Good. So that's all we're going to be doing today, solving equations. We're going to be looking at every, type of example you're going to run into. Yep.
Is 2 to the 6 the same as 5 to the 12? If you if you half the base and then double the exponent.
No.
thingy.
Nope. Okay. So let's go ahead and look at this. Okay. So here I have log base 8 of x cubed equals 12. Log base 8 of x cubed equals 12. So what do you have to do first? 8. Yep, good.
8. Oh.
So on the left side, what's going to happen is the 8 and the log base 8 will cancel. It leaves me with x cubed
Oh, this one's easy.
equals 8 to the 12th.
I don't know how to do this.
And so then now, I won't use your calculator yet, because what's going to happen is 8 to the 12th is going to be an incredibly large number. So what we're going to do is go ahead and solve for x. If I want to go ahead and solve that for x,
-3.
I'm going to go ahead and raise both sides to the 1/3 power. Okay? And so now, if I have x to the 3rd raised to the 1/3 power, that's going to leave me with x equals, here I have 12 times 1/3, which is really 4. So now my answer is actually 8 to the 4th, which is
4,096.
4,096.
Orange.
Okay. All right, let's look at another one. This is just like the very first one we looked at. Okay. So, what's the very first thing I'm going to do?
Okay, minus or plus 4 or minus 4.
Okay, very first thing you're going to do is you want to isolate the logarithm. So in order to do that, we have to subtract the 4 first of all. So on the left side, I'm left with -3 log of 5x equals 12. Next step you can do is divide by -3. So I end up having log of 5x equals -4. Next step, we've got a 10 here, so that's really 10 to both sides. So I end up having 5x, because those two cancel, equals 10 to the -4th power. Okay.
Is that negative?
So 10 to the -4th power on your calculator, if you do a 10 with a caret, -4, what does it equal?
1e -4.
Okay, so this says 1e, what?
1e -4.
Okay, 1e to the -4, that's what 10 to the -4th is.
That's what it says.
Okay. So what I want you to go ahead and do is divide that by 5.
2e to the negative fifth.
Okay? So when it says 2e to the negative fifth, what that means is that I'm going to put the number 2. I'm going to put a decimal. That e to the negative fifth means that you're going to go backwards 5 decimal places.
So
The negative means a small number. A positive 5 would mean a big number. So I'm going to go 1, 2, 3, 4, 5. And then fill those in. And then that is your answer. Okay? Okay, let's look at another one. Lots of them. You're going to have probably about 4 more that we're going to look at.
Gosh, I need you.
So, what do you think you should do here? What should you do here to solve?
You should take a 3.
3 to
And
both
put on both
sides.
sides?
Yep, very good. So on the left side, after those cancel, that leaves you with x squared minus 1. On the right side, I have 3 to the 4th power, which is what? What's 3 to the 4th power? 81. What do you do now to solve that? Add 1. So I really get x squared to equal 82. How do you solve that now? The square root. Important thing here to remember is both the plus and the minus. So x equals plus and minus 9 point what? 0.06. Good job. Okay.
I'm just curious.
So let's go ahead and look at this one, number 5. Okay, so on this one, no, you can't just do 4 and get rid of all the logarithms. The only way you can do that is if you have a single log on each side. So what I'm going to do is I'm going to condense the right side so that it's just log base 4 of a quantity. Okay, so how can I condense this right side? Not 2. How can I condense it? Remember, that was one of the questions on your quiz. Condense meant write it as a single logarithm.
Square.
X over x.
Not x over,
X squared.
times.
x times. Good. It's times because this is plus. If that would have been minus, you would have divided. Yep.
Oh.
So then now, since you've condensed it down to the logarithm of a single quantity, now is when I can just raise both sides to the 4. Get rid of this and have x. Get rid of this and have x times x minus 2. And so now we just have an equation that we need to solve. Now we have to be really careful here, okay, because I think some of you probably are going to want to do something that's technically not legal,
That's not
okay? What you need to do here is you don't want to add the 2x to both sides. Don't want to do that. Okay, if you do that, you're going to lose the solution. What ends up happening here is we need to actually subtract x from both sides. And when I do that, I get x to equal x squared minus 3x. Now, do we remember how we would solve that equation? You've got 2 terms.
Put one on that side.
You got 2 terms. Yes. And how would you do that?
Take an x out.
Take an x out, and that leaves you with
X minus 2x.
x minus 3.
Oh.
So you have 2 solutions. What will this solution give you?
X equals 1.
X equals,
0.
okay. What will this solution give you?
Negative x equals 3.
3. Now, I'm telling you that one of those is correct, one of those is not correct. Can somebody tell me which one is not correct and why?
0 because it's not.
0.
Because it's 0.
Can't have a 0. And the other thing is, if I plug 0 in here, what do I get? You get a negative. Can't have a negative either. Remember, that was not defined. So your answer is actually just 3. Okay. Alrighty, this one. Yep. Yep, get rid of the logarithms by raising both sides to the 3. Okay, so I end up having x squared plus 3 equals 52.
X squared
X squared equals
49.
Yep, x squared equals 49
I did 7! Plus or minus.
plus or minus 7. Good call. Because now you have to take the square root. So your answer is actually just plus or minus 7.
I like simple ones like what?
Now this one is one that we haven't looked at yet today, but it's not overly difficult to solve. Okay, what ends up happening is we need to somehow get rid of the 4. And so when I think about 4, I know that the log base 4 will cancel out with the 4. So I'm going to do that on the left side. I'm also going to do that on the right side. So what ends up happening on the left side is that cancels and it leaves me with x equals. And I have log base 4 of 13. Now the question is, how do I do this? Well, this is one of those problems we use the change of base formula on. Okay, if you remember change of base formula, natural log of the outside divided by natural log of the inside. You can also use a logarithm of that. So on your calculator, go ahead and evaluate that. I would like your answer to 2 decimal places.
1.85.
1.85. Okay. So now if you plugged that back into the original equation, 4 to the x equals 13, if you took 4 to the 1.85 power, you're going to get something pretty close to 13. We have one more short problem, and then that'll be it for today. Oops. So let's go ahead and go back to that one. We have e to the 4 minus 3x, and that's going to equal 6. Okay? E to the 4 minus 3x, and that's going to equal 6. So can somebody tell me?
Does it involve something like putting in an ln?
Ah, yes it does.
Yeah, because that
ln. Take the ln of both sides. That's exactly right, because what do you know happens with ln and e?
They cancel.
They cancel. So on the left side you have 4 minus 3x. On the right side I have ln of 6. So normally we don't like to evaluate till the very, very end. Okay, and so we normally would do that. However, in this problem I need to know what ln of 6 is. So to 2 decimal places, what is ln of 6?
Oh!
What was that?
1.79.
1.79.
Yeah.
So what am I going to do now?
Minus 4.
Subtract 4. Okay, so I end up getting negative 3x to equal negative
2.1.
2.21.
Yeah, that's what I meant.
Okay, I'm going to go ahead and then to solve that, divide by negative 3. And so then your x should equal 0.74, you said? Okay. Alrighty, so x is 0.74. So we've given you quite a few examples of exponential and logarithmic equations. Assignment, page 196, 11 through 20, and then 28 through 37.